I'd like to discuss the work that was accomplished to improve the capabilities and interoperability to share water resource information across borders. And in the case here studied in this instance involved U.S. and Canadian resources. The problem, as stated, is where different hydrologic data is stored and exchanged in different hydrologic models and schema. That's one of the parts of the problem. Another is the information requested is available in different formats conforming to each of the different models, different schema formats, different schema. And the water information from different models may have been have different names and have different meanings. So in this part, really the goal of this part of the thread was to provide a means to request cross-border water information using the terms that a user understands in his own national hydrologic model, such as NHD in the US or NHN in Canada, to include data that originates in both the US and Canada that adheres to the different hydrologic models. So the question is, how can this be done? So what we did to achieve this cross-border interoperability of the hydro models and to associate the data, the project used a common hydrologic feature model known as HY features. This meta model for hydrologic features was used to provide the mappings between the models for NHD in the US and NHN in Canada. Now the diagram shows on the left shows the HY feature model as it exists within the OGC's general feature model, and we use that to create model-based, well-established and accepted relationships and terminology for the water resources. The diagram, part of the diagram on the right, represents the results of efforts to map the features from HY features model to the NHD, in this case, for a selected set of feature types, in this case the flow line, and the mappings for NHD and the corresponding examples for NHN were prepared and stored in semantic query and stored for semantic query and retrieval to mediate the model differences between each of the models. So the mappings described in the previous slide were then implemented in a solution architecture as shown in this diagram. The national hydro data sets of the US and Canada were provided by the Hydro Data Services components shown on the right. The hydrologic data was accessible via SQL interface to a database and also as via a web feature service. The hydro modeling clients shown on the left were developed to test and demonstrate the capabilities of the solution architecture. These clients were used to initiate a request to the hydro model service implemented as an OGC web processing service, or WPS. The model service issues the request to the hydro mediation service, which uses the stored model-to-model mapping information to translate the terms of the query into a form understood by the source database, for example, NHD or NHN, and the results of the query were returned and transformed through a mediation of model services into the hydro model schema format requested by the originating user client. So the achievements in this part of the project really was intended to, and I believe we were able to accomplish, at least to start, a demonstration of how the HY feature model could be used as a bridge between different hydrologic data models. Out of this work also developed a semantic mapping concept between NHD, NHN, and the HY features model. We implemented a Sparkle endpoint for querying the data model mapping information, and implemented a mediation service using a standard WPS as a means to access that mapping and mediation information. So challenges for the future, really to develop a formal standard mapping framework using RDF to enhance the interoperability of mapping concepts. In this particular project, we only took just a select single feature in order to demonstrate the capabilities and the concepts on how you would accomplish this. But to really ensure a greater degree of interoperability and usefulness, you should really do that for the entire model itself. Identify common patterns and exemplar mappings to support development of tools for a sustainably reusable process. Some of those patterns and concepts were developed in this architecture. Perhaps there's additional work to be done to improve that architecture, but at least it's a start. And a full national hydro model mapping solution would be much more complex than the use of one feature, obviously, as done in this instance. So there's a good deal of work to be done in order to go from a single feature sample demonstration to really building out a capability with a full national hydro model mapping solution capability. So